like to keep things running on time here at ARC, so I believe it's 4 o'clock, and so we're going to begin. My name is Paula Hollywood. I'm a senior analyst at ARC Advisory Group, and I cover asset performance management and how that fits into IoT and all that kind of good stuff. I've been following that space for quite a number of years now, at least on the APM side. Before we begin here, I have a couple of announcements. At 5:30, there will be a happy hour sponsored by Wind River. That was originally scheduled to be outside, and however, it looks like it's going to shower, and that's been moved to Crystal A and B, and that's kind of down in the other corner. I had breakfast in there this morning. It's just fine. Okay, and then 7 to 10, ARC is hosting a reception and light dinner, and that's out in the hotel atrium where all the people are. They'll all be there. Okay, and please don't forget to use your conference app to rate the session and speakers. Please be kind to us. Okay, we're going to talk today about IT, OT, ET convergence, merging the physical and virtual worlds. And this is a session that we started last year. We actually had one and put forth some ideas and had some good discussions. So it's still evolving. I think it's not being used as much as maybe it could be, maybe in various forms, and we'll get into that a little bit and hear some stories and have some good questions. So I will give a short overview, and then I'm going to call Jason Hamlin, Process Automation Manager from Lynchburg Water, to speak. He's got some very good ideas, as well as Blair Frazier, Manager of Reliability Solutions at Lakeside Controls. And then we're going to have, I'm sorry, I don't have Russ's picture up here because he's the latest addition, but he's going to be joined by Albert Roykers, from the CEO of Bedrock Automation, and Dennis Belanger, Director of Business Development, Emerson Automation Solutions. And Russell Viciedo from Tata Consultancy will also be joining our panel. So before I start, I'm just going to say that my hope for this session was to get a full-blown digital twin user to stand up here and tell their story. However, that was very hard to come by. So we're kind of going to be nibbling at the fringes here, because their digital twin can actually take many forms when you come right down to it. So we're going to hear about some of those and what the potential could be. Certainly, I'm wondering if that has anything to do is a commentary on the state of adoption of digital twin, and hopefully we'll explore that a bit more in the panel session. But one thing to be sure is that the digital twin is not a magic wand and baby steps, and we're really going to kind of hear about baby steps today. And I hope that will suffice, because I think it will. Because, again, it's pieces. So what really is the digital twin? It is a physical product in a real space. It's a virtual replication of an as-designed, as-built, and as-maintained physical entity. They are a virtual representation of physical equipment, products, and objects. Data from the IoT is connected to the twin, and what we see as the real value of a digital twin is cost-effective visualization and simulation environment for product and process design, training, and work. So it's actually a dynamic data archive, when you get right down to it, of historical and real-time information. It's a cost-effective means to apply an iterative process to design, optimization, and workflows, training, you name it. Up to now, it's been expensive to do these things because it had to be performed on real things. Just think about crash testing a car and what the impact of that is and how expensive that can be and how much costs can be removed by doing that electronically as opposed to crashing a real car. Of course, you still have to do that at some point, but you might not have to crash as many cars. That makes a big deal. From a maintenance perspective, this will have a huge impact on safety, training, operations, and maintenance, actually. So what do we see as the functions of the digital twin? We see it as a 3D representation of an asset, including underlying components and parts. It can be used for real-time condition monitoring. We're going to kind of hear an example of that today. It can be used for automatic diagnosis based on ongoing comparisons of forecasted versus actual outcomes. It can be used for predictive maintenance alerts and recommendations. Again, iterative process, what-if simulation, modeling, recommendations and modifications based on operating conditions, and we're going to hear about that today. It's a digitized service record history. It is electronic, simplified technical documentation for support and service. It's augmented reality for service techs and end users. That's on big display in the showcase if you've been around and put some of those things on. And it can also be used for e-commerce and parts ordering. Despite the fact of not having any volunteers for a full-blown digital twin, we do believe that this market or the usage of the digital twin is set to explode. And the next big thing that is really going to have an impact is the mixed reality. Again, go to the showcase, see what's on display in there. There's several vendors showing mixed reality solutions. The beauty of that is it enables workers to view and interact with data differently. It's as an overlay to fully virtualize the equipment that's being worked on, as you can see in the photograph there. Because we can do so many things, we can help boost the equipment life cycle, definitely from concept to design to production. To date, the digital twin has been seeing most use on the design and build side, design side, design and engineering, as opposed to the operational side, but it's definitely migrating. It is applicable generally to mass-produced things like goods and food and drugs, but certainly also to workflows and training for sure. And the digital twin can take many personas. Whether it's a complete asset, be it a car or a plane or a component, like this, I'm guessing that's a manifold. Not really sure. The OTS simulator is probably the one that people are most familiar with, and the process simulator. I think more automation companies and DCS suppliers are probably concentrating more on these process simulators. From the APM side, we see it have usefulness for asset health monitoring applications, for optimization, for business overall, performance, operational performance, obviously operations and maintenance, and reliability management. It is a great simulation tool for new models and augmented reality. We definitely believe that augmented reality is going to change how maintenance is performed. So we really think that the value of the digital twin lies in its ability to tie the past with the present and into the future. So learn from the past, live in the present, and believe in the future. So we use those 3D models and service records and historian data from the past, combined with the current state and the sensor data and our current performance data, to give us insight and to simulate failure modes and make predictions. The benefits are an integrated view of any product or process. We see, obviously, the huge potential in product design, even though that's not the focus here. For custom-made-to-order products, it's going to be huge. It's not just for complete systems, though. It can also be individual components, as we saw, and sub-assemblies and work processes. Augmented reality, again, is the huge opportunity, because visualization is the basis for a common understanding. We don't get, Jason and I were just having a conversation about language and the procession that perception that certain words leave, and the visualization that a digital twin provides removes some of that ambiguity, if you will. An example for reports of development times, time reductions on complex products by 25% with a cost savings of 10 to 15%. I think that's a compelling story, a compelling savings. Engineers can simulate the behavior of complex systems to prevent and predict breakdowns. However, we still have some challenges with digital twin. Data integration, digital fragmentation, scalability of the platform, the culture, whether it's getting the right visibility into work to the right people or whether people are resistant to using this technology is a challenge. It could be a little scary to some people. And right now, I think we're at a lack for use cases. That's what I was hoping to bring forward for this conference. Maybe next year. We'll do it again next year and see what somebody can bring. And cybersecurity is obviously a big issue. And if we don't get that solved, I think IIoT is really going to have a problem being adopted because cybersecurity is so important. As the speaker from Duke Energy this morning said, he was ready for the bunker after all of the cybersecurity he went through the day before. So anyway, that concludes my remarks. And I'd like you to hold your questions until the end for the panel session. And I would like to call Jason up to give his presentation, please.